Good day, you are welcome to another unit of Physics 191, which is experimental physics. And in this unit, we'll be looking at an experiment related to vibrations of a fixed spring, and that is with the use of the single wire sonometer. At the end of this unit, you should be able to set up the vibrations of a fixed spring, that is the single wire sonometer experiment. Secondly, you should be able to measure and record the values of the resonant length L and the corresponding tension T in the spring. Then you should be able to plot a suitable function of L and T to get a straight line and calculate M from the slope of this line. And finally, you should be able to state the possible sources of error and calculate an error in the value of M. Now, the method involved in this single wire sonometer experiment, I'm going to itemize the method and try to follow it systematically. It is very simple. The first thing is that you place your weight of about 2 kilograms in the scale pan attached to the wire of the sonometer. Get a weight of about 2 kilograms, or 2 kilograms rather. Place it in the scale pan attached to the wire of the sonometer. Then adjust the two bridges of the wire. When you adjust the two bridges of the wire, make sure that the distance between them is about 10 centimeters. And when you have done this, place a small paper rider. Just get a small paper rider on the wire in the middle of the two bridges between the 10 centimeter distance you have created. And then place the end of a vibrating tuning fork. Get a tuning fork, place the end of the vibrating tuning fork on one of the bridges or on the sonometer box. The essence of this is to create a vibration on the wire. The tuning fork that is already vibrating, when it is placed on the wire on the sonometer box, it is to produce a vibration on the wire, which will agitate the paper rider. Then slightly increase the distance between the two bridges. You know, you started with 10 centimeters. Now, increase the distance between the two bridges and try the vibrating tuning fork again until the paper rider agitates violently and is thrown off. Now, the position of resonance, that is where it is thrown off, is what we refer to as our resonance length. The position you are able to achieve, the distance between the two paper riders, between the two bridges rather, that you are able to achieve for the resonance to occur, for the paper to be thrown off, that is your resonant length between the two bridges. Then increase the load on the wire by half kilogram. You know, you started with 2 kilograms, so increase the load by half kilogram each. Then for each of them, find the new resonant length like I have explained, and you repeat it for 6 values of load. So you can tabulate. You have 6 values of load, your weight that you put on the scale pan. You have 6 different values of the length between the bridges, and with that you can definitely obtain the frequency of the vibration. How do you obtain the frequency of the vibration? You see this equation, F equals to 1 over 2L square root of T over M. T is the tension in the wire, M is the mass per unit length of the wire. When you plot a suitable graph of L against T, you definitely find your M from the slope of this line. You linearize that equation given to you, plot a graph of L against T, then from your graph you obtain your slope. From the slope, you definitely obtain your M. In this unit, you've been able to learn how to set up vibrations of a fixed spring. That's the single wire sonometer experiment. You've also been able to measure and record the values of the resonant length, that's L, and the corresponding tension T in this string. Also, you've been able to learn how to plot a suitable function of L and T to get a straight line and calculate M from the slope of this line. And finally, you've learned how to state the possible sources of error and calculate an error in the value of M. This is the end of this unit on single wire sonometer experiment. Thank you.